Hey, calculus students, this is section 9.1, but it's just a little intro to series. You don't have these notes, although I will post them on Classroom. If you want to look back at them later, I'll post them with the answers. This came from College Board in spring 2020 when school was closed down and they had to teach all these sequence and series lessons online, and I thought this was a nice intro for series, kind of something you can refer back to if you're ever getting confused about series. So the situation is 3 students decided to take a much needed break from studying for the AP exam and split a pizza. However, they approached the division of the pizza in a very interesting way. So 3 students cut the pizza into 4 equal slices. Each student takes 1 slice, leaving 1 slice left over. All right, so these go to the students. This is your leftover. So if you think about what each student has, Alicia has a 4th, Ben has a 4th, Carlos has a 4th, and there's a 4th left over. The 3 students then proceed to cut the leftover slice into 4 equal slices, where each student receives 1 of those new slices. So now, if you think about, say, what Alicia has, she has 1/4, what she originally had, and now she has an additional 1/16. So that's taking the leftover and cutting that into 4 equal slices, which is the same as cutting the whole pizza into 16. So what she has is 5/16. And that's what the other students have, 5/16. And now the leftover is 1/16. Okay, so they do that again. So they take that leftover piece, that little tiny sliver, and they slice the 1/16 leftover slice into 4 equal slices. So now if you think about what each student has, they have the 1/4 plus the 1/16 plus 1/64, that little tiny sliver. So they each have 21/64, each of them. And then what is the leftover now? It is 1/64. All right, so you kind of get the idea of where this is headed. They continue on and do it one more time. So now we have, I'm not going to do all of them. I'm going to start from the 21/64, and then this time we're adding 1/256. So now each student has 85/256. Okay, and the leftover is 1/256. Okay, so how much of the total pizza will each student receive? So this is what they have right now. 85 divided by 256, which is approximately 0.33203, which is about 1/3, right? Which makes sense. Take a pizza, divide it among 3 students, they would each get 1/3. They went about it a different way, but you can see that the sum of all their pieces is about 1/3. So this is a good introduction to series. So from practical to conceptual, putting it all together. The fractional slices of pizza, here they are, 1/4, 1/16, 1/64, are called the terms of a series. Okay, each student's fractional amount of pizza after each cut, so the 1/4, 5/16, and 21/16 are called the partial sums. So this is how much pizza they had after each slicing episode. And remember, the way we got those was we were summing up these individual slices. So those are called partial sums. Somewhere along the way, you stop and sum these up. Partial sums. Because the total fractional amount of pizza each student is receiving was approaching 1/3, right? That's what we found up here. We say that the limit of the partial sums or the limit of the series is 1/3. So series are when you're taking your terms and you're adding them together. Partial sums are when you take some of your S-O-M-E, some of your terms, you stop and add them up. That's a partial sum. And then we say the limit of the partial sum. So think about if you're taking the limit as the number of your terms approaches infinity and you're adding them up. We say that is also the limit of the series. So an infinite series means you're adding up these terms forever. The limit of an infinite series could have a value or a sum. So here's just another little kind of easy to think about example. A chocolate cake is divided evenly among 4 students. So think, okay, 4 students. It's going to be 1/4 they're each going to get. Here's the students, but they're continually dividing it into 5 equal slices. So write the first 4 terms and the general term of a series that would model the amount of cake each student receives after each cut. So it's similar to what we did with the pizza, but we're dividing it into 5 slices, the cake, instead of 4. So our first slice will be 1/5. And then tip the leftovers, divided that into 5 slices. So the second slice they get would be 1/25 of the cake. This third slice would be 1/125 of the cake. The next slice they get, which would be incredibly tiny, would be 1/625. So a general form for this, you probably noticed, you might have noticed it on the example above, is 5 to the n. This is 5 to the first, 5 to the second, 5 to the third, 5 to the fourth. So this is how I can represent this sequence in a general form. How much of the total cake will each student receive? Well, we kind of already talked about that. We know it's going to be 1/4, but I'm just going to show you. I'm going to add up these. Ooh, it's already in there. Let's just keep that. I already did that. So I added up the 1/5, the 1/25, the 1/125, and I got 0.248. And then I added on the last slice, the 1/625, and I got 0.249. So you can see, here's my first partial sum, which was 3 terms. Here's my second partial sum, which was 4 terms. You can see it's approaching. If you did another one, you'd get even closer to 0.25, which is 1/4 or 1/25, right? I'm sorry, 1/4 or 0.25. So that is the limit of the series or the limit of the partial sums. Both are the same. They're going to be 1/4. So then leads to a definition. Okay, so this is a series. We have the terms and we're adding them. So we have that summation symbol out front. We're starting at 1, we're going to infinity, we're adding up all these terms. We call this an infinite series because we're going from 1 to infinity. So it says if the sequence of partial sums, remember this is when you kind of stop somewhere and you add up some of your terms. If your sequence of the partial sums of an infinite series has a limit, so for example, in the pizza example, ours had a limit of 1/3, then the series converges and it is said to have the sum S. So if my partial sums have a limit, then I can say my whole series converges to that sum. And then it says, note, if the limit of your partial sums approaches infinity or negative infinity, then your series diverges. Doesn't approach a value, approaches infinity or negative infinity. So then your series diverges, the whole series. So here they're saying if the partial sums approach infinity or negative infinity, then the whole series diverges. Or if the limit of the partial sums does not exist, then the whole series diverges. Okay, this gets to your first test for divergence. This one is just for divergence, and we'll talk about this more in class, but I'm just going to show you quickly. So this says, this says if you have a series and you know it diverges, then you know the limit of the terms are not equal to 0. But what is more interesting is if you do it in reverse. So if you take the limit of the term and it equals 0, then you don't know at all if it converges or diverges. But if the limit does not equal 0, then you know the series diverges. So that might seem a little quick right now, but we will go over it more in class. But I wanted to show you these examples because they put a graph with them, and I think the graphs are pretty telling. So if I'm doing that nth term test above, what I'm going to do here is I'm going to take the limit as n approaches infinity of one term. Okay, so here's my series, adding all these up. I'm just going to take one term, which is just the n over 2n plus 1. And I'm going to take the limit as n approaches infinity. So this is the same power thing happening. And remember, as I'm approaching infinity, I ignore constant terms. So this limit approaches 1/2. Okay, so 1/2 does not equal 0. So therefore, the series, when I'm adding them all up, diverges. Okay, that's what the nth term test tells you. So let's do one more, and then I want to show you the graphs on the next page. So limit as n approaches infinity. In this case, my a sub n, or my term, each term is 1 over n. Well, we know if the bottom is infinity and the top is a constant, I'm approaching 0. So therefore, the series, we really don't know. It may converge or it may diverge. Okay, so if it doesn't equal 0, we know it diverges. If it does equal 0, we don't know. Could be either. Same thing for this one. If you take the limit of 1 over n squared, it's going to approach 0. So this series, maybe it converges, maybe it diverges. We don't know. If you take the limit of this one, we would have to L'Hopital it, but we would still get 0. So again, these, all of them except the first one, we don't know whether they converge or diverge. So I think looking at this graphically helps to make it a little bit clearer. So these are these same examples. So this first one, it's hard to see, but this was the n over 2n plus 1. So this was the one where we said it approaches, the limit of a sub n approaches 1/2. So we said it diverges. So here's the graph of just the term. You can see this line right here is 1/2. So it's approaching 1/2. If you look at the series, it's going up forever. So this series is approaching infinity. So that is diverging. The next example, hard to see, but this was the 1 over n. So we said the limit approached 0. So you can see here's the graph of 1 over n. It's approaching 0. Now, when you look at the graph of the series, this looks, I mean, it's hard for us to tell, but it looks like it could be diverging. It could be going up forever, or it could be converging. Looks like it might be approaching an asymptote here. So this just shows you, we don't, this we said we couldn't tell whether it converged or diverged. Here, when we looking like it maybe converges. This was the 1 over n squared, approaching 0. The series clearly looks like it's converging. So this one, so let me compare the last one. The last one was the natural log one, natural log of n over n. We said it was approaching 0. It is, obviously slower. When you look at the series, though, this is approaching infinity. So this one is diverging. This one clearly looks like it's converging, even though when we check the limit of each term, we got both of them approaching 0. So this graphically shows you, it doesn't tell you what's happening with the series. You could go either way. Okay, so that is just a quick intro for you.